In the previous video, we have 4 tasks and we have 4 workers, and we have the cost associated with each worker task combination, right? For example, worker 0 takes $90 to complete task 0, right? So the objective is to assign the 4 tasks to 4 workers, 1 task per worker, so that we minimize the total cost to complete all the 4 tasks. So what we did is we posed this problem as a network flow problem. So we have added this fictitious source and fictitious sink, right? So here we have the 4 worker nodes. Here we have the 4 task nodes, and each worker can take any task. So each worker node is connected to 4 tasks nodes, right? Then we have the source and sink. So at the source, we have started with 4 tasks and we have completed them by flowing the 4 tasks through this network, right? So in this video, we make the problem a little complicated, and we also introduce the teams concept. So in a real world scenario, we might often have teams, maybe based on people's skill set or some other factors, right? So this time we have 6 workers, okay, worker 1 to 6, and we have the same 4 tasks, okay, and these numbers, they represent the cost pair, okay, between the worker and the task. Now what we are adding is, here we have 2 teams, team A and B. So team A consists of workers 1, 3 and 5. Team B consists of worker 2, 4 and 6. Okay. So each team has 3 workers. And we also have additional constraint that each team can do only 2 tasks, right? Maximum 2 tasks. So which means, for example, let's say worker 1 and 3 got, let's say, task 1 and 2, which means worker 5 from team A does not have any work. Okay. Similarly, for team 2 also, we want to assign 2 tasks. We don't know which worker from team 2 is not going to get the work, but that's not important. At the end, we again want to minimize the cost to complete the 4 tasks. Okay. So compared to the previous problem, we have 2 additional constraints. The constraints are, we have 2 teams, each team consisting of 3 workers, and for each team, we want to assign maximum 2 tasks. Okay. So let's see how we do that. So it's the same cost matrix. Here we have just did a bit of processing to show this as a pandas data frame. And then we have team A and B, and the maximum tasks per team is 2. Okay. So we are just printing how many workers and tasks we have. We have 6 workers and 4 tasks. So what we are going to do is, we are going to construct another network. But this time, because we have 2 teams, in order to be able to group these 6 workers into 2 teams, we are going to introduce 2 additional fictitious nodes. Okay. For example, here we have the source, which is where we have the 4 tasks. And then here we have team A and team B, which are represented as node 11 and node 12. And so that's one constraint we have applied, right? And then we want to assign only 2 tasks per team. So here we are saying the maximum capacity is 2, which means the 4 tasks at source, they gets divided into, for example, only 2 tasks can be assigned to node 11, and the remaining 2 tasks must be assigned to node 12. Okay. So node 11 is team A, node 12 is team B. So from node 11, as you can see, we have connected it to only 3 workers, right? So unlike here, where everything is connected to everything, here we are carefully constructing the network so that from node 11, the tasks can flow to only worker 1 or worker 3 or worker 5. Similarly, from node 12, the task can go to worker 2, 4 or 6. Okay. Now it's not a complete diagram, but these worker nodes are connected to tasks nodes, which are 7, 8, 9 and 10. Okay. 7, 8, 9, 10, 4 task nodes. And finally, we have the sync node, which is number 13. Okay. So we are using 11 and 12 for the teams. Okay. All right. Very quick summary. In order to satisfy these two constraints, we have introduced two fictitious nodes, node 11 and 12. And because these represent teams, each node is connected to only 3 workers who belongs to the team. And then to satisfy the second constraint that each team can get only two tasks, we have defined the capacity as 2. All right. And then we need to define these 4 arrays, arcs in the form of start and end nodes, and then the capacities and the costs. So from our source, which is 0, the flow can go either to node 11, which is team A, and from 0, it can go to node 12, which is team B. Okay. And then once we are at node 11, the flow can go only to team A. So team A, we have 3 workers, right? 1, 3, 5. So here we have 1, 3, 5. Similarly, from node 12, it can go only to 2, 4 and 6, which is team B. And then from the worker nodes, for example, worker node 1, he can get any work, right? Out of those 4 works, the worker can get any work. So our task nodes are 7, 8, 9, 10, which are not shown here, but here we have 4 tasks nodes, 7, 8, 9, 10. So each worker is mapped to the same 4 task nodes. Okay. And finally, from the task node, we close the loop by flowing it to the sync. So here we have the tasks 7, 8, 9, 10, and we have connected it to the sync. Okay. All right. Coming to the capacities, all arcs have equal capacity, except here where the 4 tasks are divided into 2 tasks each, and arc 0 to 11 has a capacity of 2, 0 to 12 has a capacity of 2, all the remaining arcs have a capacity of 1. So that's why here you will see these 2 arcs 0 to 11 and 0 to 12, they have a capacity of 2 each, but all the remaining ones have a capacity of 1. And finally, cost. Whenever we have a fictitious node, the cost will be 0. So that's why here you will see, so these 2 arcs cost is 0, and then cost from node 11 to its 3 workers, node 12 to its 3 workers is also 0. So this is team A, this is team B, these 3 nodes, and then the other 3 nodes. Okay. And then these numbers represent the cost between the worker nodes to the tasks node. Okay. And finally, from the task node to the sync also, we don't have any cost. Okay. So if you are able to define this correctly, that's pretty much it, right? So we have source at node 0, sync at node 13, and the number of tasks is 4. And the supplies, so we start with 4 tasks at the node, at source. We want to be able to finish all those 4 tasks at the sync, right? So that's why here we have 4 tasks, the sync is 4 tasks, and all the remaining nodes from node number 1 to node number 12, the supply is 0 at the beginning. Okay. All right. We simply instantiate the min cost flow, and then here we are adding the arcs, the capacity and the unit cost. The 4 arrays we define here one by one. We can add all of them at once using add arcs. It's a plural, right? So instead of supplying these indexed values, we can supply the whole list or array. We are doing the same thing. So for each node, we are providing the supplies. And finally, we are doing the optimization. Okay. So as I mentioned before, with the optimization problem, defining the problem itself is the difficult task. The solver will do the job for us, but defining the problem correctly, in this case, the network structure and the arcs, the capacities cost is the trickier part. Okay, so that's it. We have done the optimization, and then we are checking if we found an optimal solution. So then we are printing how much the total cost. So the total cost is $250. And then our network has this number of arcs, right? So all these are arcs. So for example, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. And then here we have multiple arcs because each worker node is connected to each task, and then tasks are connected. So everything is an arc. So here what we are doing is we are looping over all the arcs, and then the actual work happens only between the workers and the tasks nodes, right? And all these are fictitious. So what we are doing is we are just checking if the arc involve a source or a sink or node 11 or 12. So we are not interested in any of these. We are interested in only the flow between the worker nodes to the task nodes, right? So here we are avoiding all which involve source, sink, and the remaining two fictitious nodes. And then for the remaining arcs, the flow can be either 0 or 1. 1 means the flow has a value of 1, right? Which means, so for example, if you look at here, so let's say, so from worker 1, we have 4 arcs, right? So if the flow is 1 between, let's say, node 1 to node 5, which means the task 5 is assigned to worker 1. In such a case, the flow between 196 will be 0, 197 will be 0, 198 will be 0, right? Because we can assign only one task per worker. So that's exactly what we are doing here. We are simply checking if the flow is greater than 1, meaning that task is assigned to that worker, right? We are printing the tail head as well as the unit cost. So our final solution is worker 1 is assigned to task 9 and worker 5, who also belong to the same team, assigned task 10. And here we can see the cost for each task. Okay. So from team A, worker 1 and 5 got tasks 9 and 10. So worker 3 did not get any task. Okay. Similarly, from team B, worker 2 and 6 got tasks 7 and 8. Worker 4 did not get any work. So this way we are able to get the work done with $250 with minimum cost, which is the minimum cost, and also satisfying the two additional constraints, which is the teams concept and also assigning only maximum 2 tasks per team. Okay. That's all for this video. Thank you very much.